All right, Algebra 2, we're going to go ahead and do Unit 9.4. We're going to use the unit circle, so you should have one that's filled out for the degrees, the radians, and the ordered pairs. And so today we're going to look at how to use the unit circle to answer questions. And so kind of think of SOHCAHTOA, our right triangle here in quadrant 1. Again, we put the right angle on the x-axis, and then our angle theta is down there by 0, 0. And if we let the radius of this triangle be 1 unit, and the horizontal section of this right triangle, the length would be x, and the vertical part would be y, and we use SOHCAHTOA, we can see that the sine of an angle is the opposite of hypotenuse, which in this case would be y over 1, or y. Likewise, if we do cosine, it's the adjacent side divided by the hypotenuse, so x over 1 is x, and then tangent is the opposite over the adjacent side, so that would be y over x. And then we can get each of the reciprocal functions also. So when we have an ordered pair, and it's x comma y, we want to think of the x coordinate is the cosine value, and the sine is the y value. All right, so let's look at the unit circle, and we're going to kind of look at quadrant 1 here. And we want to find the sine, the cosine, and the tangent of a 60-degree angle. And so if you look at your right triangle, or your unit circle, at 60 degrees there's an ordered pair that's associated with it, and that's 1/2 comma root 3 over 2. And so the sine is the y-coordinate of the ordered pair, and so at 60 degrees. So the y-coordinate would be root 3 over 2. So that's what sine 60 degrees is, root 3 over 2. Now cosine is the x-coordinate, and so at 60 degrees the x-coordinate is 1/2. So the cosine of 60 degrees is 1/2. And then tangent of 60 degrees, well, tangent is the y-coordinate divided by the x-coordinate. So this y-coordinate is root 3 over 2, and the x-coordinate is 1/2. So it's divided by 1/2. Well, we can rewrite this horizontally instead of vertically. So that would be root 3 over 2 divided by 1/2, which is root 3 over 2 times the reciprocal, 2 over 1. Now we can cross cancel because multiplication allows us to do this, dividing by 2. Now if we multiply across, we get root 3 over 1, or just root 3. So the tangent of 60 degrees is just radical 3. All right. Now on the unit circle, we have all these ordered pairs, and we just have to remember in quadrant 1, it's positive, positive. In quadrant 2, it's negative, positive. Quadrant 3, it's negative, negative. In quadrant 4, it's positive, negative. So in quadrant 1, all the x's are positive, and all the y's are positive. And so we also want to know that in quadrant 1, since x is really cosine and y is really sine, we know that the cosine and the sine would be positive for that angle that falls in quadrant 1, along with tangent, because tangent is the y-coordinate divided by the x-coordinate. And so if you do a positive divided by a positive, it's still positive. And then all the reciprocal functions, if the originals were positive and you do the reciprocal of that function, it's still going to be positive. So what we want to remember in quadrant 1, if there's an angle that falls in quadrant 1, all 6 trig functions are positive for that angle in quadrant 1. So we want to remember all 6. Now in quadrant 2, the signs change a little bit. The x-coordinate is negative, and the y-coordinate is positive. All right, and again, x is our cosine, and y is our sine. And so we want to know when is the trig function positive in that respective quadrant. So in quadrant 2, since the y-coordinates are positive, and that refers to the sine, sine is positive in quadrant 2, along with its reciprocal function, the cosecant. Now we go to quadrant 3, we can see they're both negative. Again, cosine is negative in quadrant 3, and the sine would also be negative in quadrant 3. But if we do the tangent is the y value divided by the x, and a negative divided by a negative turns positive. That means that tangent is positive in quadrant 3, along with its reciprocal, the cotangent. Now in quadrant 4, x is positive and y is negative. Again, x is our cosine value and the y is our sine value. So we can see that the x's are positive in quadrant 4, which refers to the cosine. So cosine is positive in quadrant 4, along with its reciprocal, the secant. So when we want to know what quadrant a certain trig function is positive, then we want to memorize A, S, T, C. So all 6 trig functions are positive in quadrant 1. Sine and its reciprocal trig function is positive in quadrant 2. Tangent and its reciprocal, the cotangent, is positive in quadrant 3. And cosine and its reciprocal are positive in quadrant 4. And so we can kind of memorize all students take calculus, ASTC, to help us remember which trig functions are positive in the different quadrants. All right, so now we're going to look at finding what 2 quadrants make this inequality true. All right, so again, if you think of this, all students take calculus. Okay. So in question number 1, we want to know, when is cosine less than 0? Cosine refers to the x-coordinate, and less than 0 means negative. All right. So if we look at this ASTC, this tells us when it's positive. So we know cosine's positive in 1 and 4. Okay. That means it has to be negative in 2 and 3. And if you look at the coordinates for quadrant 2, it's negative, positive, and negative, negative. So the x's are negative in 2 and 3. Now, number 2, cosecant is greater than 0. Well, the reciprocal of the cosecant is the sine, and greater than 0 means positive. So we want to know what 2 quadrants is sine positive. All right, well, we know, according to ASTC, we know sine is positive in 1 and also in quadrant 2. Again, sine is the y-coordinate, so you're just trying to find on the y-coordinates, when are all the y-coordinates positive? Well, we know all the y-coordinates are positive in 1 and 2. All right, now questions 3 through 6, it's going to be basically the same thing. We're going to have 2 quadrants for each inequality, but then one of the quadrants is going to repeat, and the quadrant that repeats is going to be the actual answer. So the question says, find the quadrant that theta lies in where cosine is less than 0 and cotangent also has to be less than 0. Okay. So we know cosine is x, and less than 0 means negative. So we know that cosine, or the x values, would be negative here and here. So that's 2 and 3. So again, look at your unit circle. Now it says cotangent has to be less than 0. Well, cotangent is the same signs as what tangent would be. So we want to know, when is tangent, which is the y divided by x, when would that be negative? Well, if we look at all the y-coordinates and the x-coordinates, the only way they're going to be negative is if they're opposite signs. So we know they're opposite signs here in 2 and 4. And so for cotangent or tangent being less than 0, the answer would have to be either 2 and 4. All right, now there's one quadrant that's going to repeat. And you can see quadrant 2 is repeating. So quadrant 2 is going to make both inequalities true. So quadrant 2 is going to be the answer. All right, question 4. When is sine greater than 0? All right, so sine is the y-coordinate. And so when is the y-coordinate greater than 0 means positive? Well, when it's positive, it's easy to kind of look at ASTC. So we know sine is positive in 1, because everything's positive in 1, and also quadrant 2. Secant is greater than 0. Well, let's do the reciprocal of secant, which is the cosine. And when is the cosine, which is x, greater than 0? That's positive. Well, again, according to ASTC, we know cosine is positive in quadrant 1 and in 4. So one quadrant repeats, and that is quadrant 1. So quadrant 1 is the answer. All right, number 5. Cosine is greater than 0. Okay, so again, that's x. And greater than 0 is positive. So that would be 1, because everything's positive in quadrant 1. And then it's also positive in 4. Tangent less than 0 means it has to be negative. And the only way y divided by x can be negative is if they're opposite signs. So they're opposite signs, again, in quadrant 2 and 4. And so you can see the quadrant that's repeating here is quadrant 4. All right, 6, cosecant less than 0. So the reciprocal of the cosecant is sine. Sine is y. And so on our unit circle, when are the y-coordinates less than 0, negative? Well, if sine is positive in 1 and 2, that means it has to be negative in 3 and 4. Again, just look at your ordered pairs. You'll see all the y values are negative in 3 and 4. Secant, which is the reciprocal of the cosine, when is that less than 0? Okay, so cosine, again, is our x values. So when are all the x values negative? All right, so the x values are negative in 2 and 3. And so the quadrant that's repeating is quadrant 3. So that's going to be the answer, quadrant 3. All right, so now we're using the unit circle to find the value of each of these trig functions. And so you're going to look at the angle that they give you. So in number 7, we're going to first look at the ordered pair for 90 degrees. So at 90 degrees, the ordered pair is 0, 1. Now, you don't have to write all these ordered pairs down. I'm just showing it to you because I can't visually show it to you on the unit circle. So 90 degrees is 0, 1. And so the sine is the y-coordinate of that ordered pair. And so the y-coordinate of the ordered pair is 1. So the sine of 90 degrees is 1. And you can put that in the calculator just to double check that, and you just put in sine 90 degrees equals, and it should come out to be 1. All right, cosine 45. All right, so the ordered pair for 45 degrees is root 2 over 2, comma, root 2 over 2. Cosine is the x-coordinate of that ordered pair. So the x-coordinate is root 2 over 2. Now, if you put cosine 45 degrees in your calculator, most of your calculators are going to give you the decimal of root 2 over 2 is. You know what that is. Some of your calculators, you could probably find the exact answer, and it'll give you root 2 over 2. But again, you want to practice using the ordered pairs because you probably won't have a calculator to use on the test. All right, cosine 3 pi over 2. All right, so 3 pi over 2 is at 270 degrees, and that ordered pair is at 0, negative 1. And we want the cosine, which is the x-coordinate, and so that's 0. All right, tangent pi over 4. So that's where 45 degrees is again. So that's root 2 over 2, comma, root 2 over 2. And tangent is the y divided by x formula we want to remember, y over x. So if we take root 2 over 2 and divide it by root 2 over 2, that's the same as root 2 over 2 times 2 over root 2. Okay, we'll cross cancel all this stuff. Since everything cancels, it's 1. And you should also recognize that if you took anything and divide it by itself, it's 1. All right, so root 2 over 2 divided by root 2 over 2, since they're exactly the same, it's going to simplify to 1. All right, sine 135, so let's find 135 on the unit circle. And so that's at negative root 2 over 2, comma, positive root 2 over 2. And the sine is the y coordinate. And so here's our y coordinate, which is root 2 over 2. Right? And so you can see that sine, if we think back ASTC, sine is positive. The answer is positive in 1 and 2. And 135 degrees is in quadrant 2, and it's asking for the sine, and that's why the answer is positive root 2 over 2. Where if the question was what's cosine of 135, we know cosine is negative in quadrant 2, where 135 is, and the answer would be the negative root 2 over 2, because cosine is the x-coordinate. All right, 5 pi over 4. So on the unit circle, that's where 225 degrees is. And so the ordered pair, negative root 2 over 2, comma, negative root 2 over 2. Cosine is the x-coordinate, and we want negative root 2 over 2 as our answer. All right, cotangent 7 pi over 6. So 7 pi over 6 is in quadrant 3. That's where 210 is. All right, so that ordered pair is negative root 3 over 2, comma, negative a half. And cotangent is the x value divided by the y value. So the x value divided by the y value. All right, and then we can make that negative root 3 over 2 times negative 2 over 1. Then we can cross cancel. All right, that's 1 there and 1 there. And multiplying across, negative root 3 times negative 1 is positive root 3 over 1 times 1 is 1. So root 3 is the answer. Secant 45. So 45 degrees on the unit circle is root 2 over 2, comma, root 2 over 2. Secant is the reciprocal of the cosine, all right? And cosine is x. And so, again, you can do 1 over x, 1 divided by that, and simplify it. But you could also just take that fraction and do the reciprocal. Okay, that's the same thing as doing 1 divided by root 2 over 2. Now, we can't leave a radical on the bottom, so then we would rationalize it. And so we get 2 root 2 over 2, which then we could simplify, and we just get radical 2 as our answer. All right, cosecant 30 degrees. All right, so the ordered pair for 30 degrees is root 3 over 2, comma, 1/2. Cosecant is the reciprocal of the sine, and the sine is the y coordinate. All right, so we take the y coordinate and do the reciprocal. The reciprocal of 1 over 2 is 2 over 1, which is 2. Now you could also do 1 divided by a half, okay, and then 1 times 2 over 1, and you still get 2. All right, tangent negative 180. So negative 180 is the same place as where positive 180 would be, and that's at negative 1, comma, 0. Tangent is y over x, which would be 0 over negative 1, and that simplifies to 0. So if 0 is on top, the answer is 0. All right, cosine 135. So the ordered pair, negative root 2 over 2, comma, positive root 2 over 2. Cosine is the x-coordinate, and so that would be negative root 2 over 2. Tangent negative pi over 4. Now, negative pi over 4, we're going to go in the negative direction, so clockwise, whatever pi over 4 is. Well, pi over 4 is 45 degrees. So we're going to go in the clockwise direction, 45 degrees, and that would put us at 7 pi over 4. Right, so that tells us the ordered pair that we're looking at 7 pi over 4, which is root 2 over 2, comma, negative root 2 over 2. So then tangent, we're doing y divided by x, so negative root 2 over 2 divided by positive root 2 over 2. And you should see that this is going to simplify down to negative 1. But if you don't see it, then just do all the work, change the multiplication, flip it, cross cancel all this out. -1. All right, last one. Which two angles in radians would the tangent of theta be undefined? All right, so we're basically answering this question. So trying to figure out what angle can go in there, so when we do the tangent, it's undefined. Well, we know tangent is y over x. The only way that this can be undefined is if we're trying to divide by 0, if x is 0. So we can go on to the unit circle and find out when is x 0. Well, if we start, well, at 0 degrees or 0 radians, the ordered pair is 1, 0. That's the y-coordinate being 0, not the x. If we go to 90 degrees, that ordered pair is at 0, 1. And if you do y divided by x, see, that's undefined. Okay, so one of them is at pi over 2. So pi over 2 is one of the answers. Now, if you continue around the unit circle, you got -1, 0, but that's not the x value being -1. That's y, 0. That's still y, the y-coordinate being 0, not x. And then at 270, or 3 pi over 2, that's 0, -1, we can see that the x value is 0, because if you do y divided by x, that would be -1 divided by 0, which would be undefined again. And so then that radian measure would be 3 pi over 2. All right, so that's how you can determine if a trig function is undefined, is if it's trying to divide by 0. All right, and that's it.